These are your algebra notes for section 4.5. We do have to do a couple of warm-up problems before we get into the actual notes. Please do these on your paper as well and follow along. Go ahead and write 3x plus y equals 10. And I will remind you, once again, to pause the video anytime you have time to write down the problem. I'm not going to pause it every time. If it says solve for y, it just means make sure the y is isolated. Get it by itself. Do the inverse operations on each side. If that's a 3x, you're going to minus 3x from both sides. And we've talked about this before. If you subtract 3x, you're left with just y because that cancels. What we've talked about that before is I always tell you, try not to put those right underneath each other. You're not subtracting 3x from 10 because they're not alike. You're going to put the negative 3x and the 10 in order of y equals mx plus b and keep them separated as unlike terms. Negative 3x, positive 10. That's called solving for y because y is isolated. That was a nice easy one-step problem. Let's do a two-step problem here. And again, slow it down, pause it so you have time. Negative x plus 2y equals 6. First, you've got to get the x over there, and since it's a minus x, we're going to add x. And you're left with 2y equals, and I did it again, don't write it directly underneath it. Separate them out so you know that they're not alike. 2y equals x plus 6. But the y isn't isolated yet. You have a 2 in front of it as a coefficient. So you're going to divide by 2 once, twice, 3 times, and you're left with y equals 1/2 x plus 3. And again, solving for y puts it in y equals mx plus b form. And notice I did make a slope of 1/2. Third problem, one more time, 2x minus 3y equals 9. You're going to try to solve, get y by itself. I'll step over here. So now you're going to subtract 2x from both sides. That time I remembered to put it in front. Don't lose your negative. Negative 3y equals negative 2x plus 9. Notice I subtracted the 2x because this was a positive 2. But now I have to divide by negative 3, negative 3, and negative 3 again to finish with y equals. A negative divided by a negative is a positive. 2/3 does not reduce, so you leave it as 2/3 x. Divided by negative 3 is negative 3, so I write it as just subtract 3. That's called solving for y. It's also related to our lines that now we're in y equals mx plus b form. We know our slope is 2/3. We know our base is negative 3. That was just a warm-up. So from there, we're going to go into the actual notes. Section 4.5. Section 4.5, we're talking about parallel lines. Two lines are parallel if they have the same slope. Exactly the same slope. Write that down. All right, if you're back from writing that down, same slope. Let's say I have a line here that rises 2 and runs 3. Rise 2, run 3, it does that. Another line over here that rises 2, runs 3, it does that. Those two lines are parallel. They'll never intersect. They'll never run into each other. They have the exact same slope. So this one's asking you to give the slope of the line parallel to the following examples. Write that down in your notes. You need the instructions. Give the slope of the line parallel to the following examples. Find this slope. This slope is 3. Find your new slope. What's your new slope? Well, if they're the same, your new slope is also 3. And please write it as m equals because all they're asking for is slope. Be very, very careful that you don't write m equals 3x. This x is a different part of the equation. slope m comes in front of the x. It's the coefficient. That was nice because it was all in form, y equals mx plus b. Go ahead, take the time to write this one down. But now, we don't have the slope yet because it's not y equals mx plus b. You first have to do what we did in the warm-up and subtract 2x from both sides. When subtracting 2x from both sides, you're left with y equals negative 2x plus 6. Now we know our slope, and our slope became negative 2. Well, if the slope of this line is negative 2, the slope of a parallel line is also negative 2. This isn't all we're going to do. It's going to get a step more complicated. For example, take the time to write this down. Okay, if you have that written down, give the slope of the line parallel. I will remind you the formula. You could write it down again, or you could go back and look in your notes, because we've used it plenty of times. Y's over x's. Just a friendly reminder of x1 and y1 here. x2 and y2 over there at that point. If you subtract the two y's, 5 minus 8. Subtracting the two x's, negative 7 minus negative 3. We make that a plus right away. Negative 3 over negative 4. Your slope is a positive 3/4. Give the slope of the line that would be parallel to this line. We don't know where the new line is. All we know that it's parallel. So if this slope, I shouldn't have circled it because it's not our final answer. If this slope is 3/4, that means our line that's parallel also has a slope of 3/4. That's the only information we know about it. This one gave us 2 points, left 3 and up 8, left 7 and up 5. Oops. So we know that that line went like this. We have no idea where this slope is. We don't know where the line is. It didn't give us any points, but what would the slope be if it was parallel? It would also be 3/4. The question is, where is that line? We don't know yet. One step at a time. Slow it down. Take a break. We're only finding slope at this point. And now we know it. They're the same. So there's our same slope. Aha! Here it is. Now we're going to write an equation of a line containing that point, 6, negative 4, and it has to be parallel. Look at my abbreviation for parallel. It's just two perfectly straight up and down parallel lines. Not my abbreviation, the mathematical world's abbreviation. To y equals negative 2x plus 5. Go ahead, take the time to not only write this instructions down, but also write down the formula that we've been using all along. Y minus y1 equals m times x minus x1. I'm sorry, there's a little bit of a glare up there. I hope you can see through it, but I have no way of removing that from the projector. We know y minus y1. We've done this over and over and over. Y minus negative 4, or in our world, y plus 4, equals, we need a slope. It has to be parallel to this line. If it's parallel to this line, it has the exact same slope. We don't need the rest of this information. TMI, as you would say. We don't need that. We don't really care where that happens. That's telling us where it is on a graph. All we need to know is that the two lines are parallel. So we take that slope out, stick it in here for m, they have to be the same, and continue on the same way we've been doing the last couple weeks. You're all very good at this, but keep going. Keep track of your negative 2 and negative 2, which gives you negative 2x plus 6. Negative 2 times negative 2 is positive 6. Subtract 4 from both sides. And our final answer, because it said give the equation of a line, is y equals negative 2x plus 2. Would those two lines be parallel? Yep. This one started up 5. So this one started up here. And this one started down or at 2. If we just, you don't have to write this down, but just get a visualization of a quick sketch. This one would have been up 5 and then down 2 over 1. This one would have been up 2 only, but still down 2 over 1. We would have ended up with two parallel lines. The bases are different, the slopes are the same. Number 4, I know I'm kind of cruising through this, but that's because you can work at your own pace. Pause it, slow it down, rewind it, watch it again. Take the time to write all this down, and we have x1, y1. We know it needs to be parallel, so we need a slope of negative 3. Y minus 10 equals slope negative 3 times x minus 9. Y minus 10 equals negative 3x. Guess what? I did it to you again so that you stop making this mistake. Pay close attention to a negative 3 times a negative 9, which is a positive 27. Add 10 to both sides. Make sure you add like terms. It jumps all the way over there because those are alike. Y equals negative 3x plus 37. Luckily, we don't have to graph this.